next example. In this example number 5, again, we are going to find dy dx for this parametric curve, but there is an extra question. And that extra question says, and determine the points at which the curve has a horizontal or vertical tangent line. Let's suppose that this is the curve. This curve here, this is the parametric curve. Now, these are the horizontal tangent lines, as we can see here, this and that. Now, the condition for those horizontal tangent lines is that the derivative of the parametric curve at these points, this should be 0. So that will be dy dx equal to 0 for horizontal tangent lines. So we say, for horizontal tangent lines, as we have said before, the condition is that dy dx that is equal to 0. So let's find dy dx first. So dy dx will be equals to dy dt over dx dt. Now we have y here, so dy dt will be 16 times the derivative of sine of t, and that is cosine of t. That is the derivative dy dt over dx dt. X is 4 cosine of t, so dx dt will be 4 times the derivative of cosine, which is negative sine of t. We cancel common factors. 16 over 4 is 4, and then cosine of t, we can write cosine of t for now, over sine of t, and that negative sign we can write it up front. We can also write as negative 4 cotangent of t. So we got this portion here. We found dy dx. Now, for horizontal tangent lines, we said that dy dx must be 0. So that will be our second step. Let's write this as our first step, where we found dy dx. Step number 2 will be set dy dx equals 0. And this is to find horizontal tangent lines. Okay, so let's grab this form of dy dx. All right, so let's write that in here. Negative 4 cosine of t over sine of t equal to 0. So from here, we conclude that cosine of t must be 0. If the numerator is 0, then the whole fraction is equal to 0, as long as the denominator is not 0. So conclusion from here is that cosine of t equal to 0. Now we need to solve these small trigonometric equations. So cosine of t equal to 0. So that means that t is equals to pi over 2, or t equals to 3 pi over 2. Now keep in mind that t, the parameter, is between 0 and 2 pi. So all that we need to find is the solution on this interval. So we have the solution t equals pi over 2 and t equals 3 pi over 2. The next step will be evaluate x and y for t equals pi over 2 and also for t equals 3 pi over 2. So we can find the points at which this curve has horizontal tangent lines. So we say t equals pi over 2 or t equals 3 pi over 2. So we have those two solutions. Now for t pi over 2, we are going to find the value for x and the value for y. We know that x is 4 cosine of t and y is 16 sine of t. That's what the equations are saying. So we just repeat those equations, and now we are going to substitute the value for t. T is pi over 2, so that means that x will be equals to 4 cosine of pi over 2, and y will be 16 sine of pi over 2. But cosine of pi over 2 is 0 times 4, this will be 0. And sine of pi over 2 is 1 times 16. This will be 1. So that means that we have a point, and that point is 0, 16. So at this point, we have a horizontal tangent line. Horizontal tangent line at this point. Now let's find the second point. For t equals 3 pi over 2, we find x equals 4 cosine of 3 pi over 2, and y will be equals to 16 sine of 3 pi over 2. Cosine of 3 pi over 2 is 0 times 4, it will be 0, so we have x equals 0. And then sine of 3 pi over 2 is negative 1 times 16, that will be negative 16. So y will be negative 16. And we have another point at which the curve has a horizontal tangent line, and that will be 0, negative 16. All right, so we have to answer this point and this point for horizontal tangent line. Okay, now vertical tangent lines. For vertical tangent line, let's find the points at which the parametric curve has vertical tangent lines. So we say that for vertical tangent lines, we are going to set dx dy equal to 0. So let's take a look at our dy dx. dy dx, we found it here, and we have as equals to negative 4 cosine of t over sine of t. Dx dy will be the reciprocal. That will be sine of t over negative 4 cosine of t. So let's write that in here. So that means that this is sine of t over negative 4 cosine of t. And we set this equal to 0. And again, if this fraction is equal to 0, then the numerator must be 0. So from here, the conclusion is that sine of t is equal to 0. Now let's solve this small trigonometric equation. Sine of t equal to 0, which means that t is equals to 0 and t equals to pi. That is on the interval from 0 to 2 pi. We can also write t equals 2 pi, but since sine is periodic and the period is 2 pi, then basically this point corresponds to that point. So we can just use this 2 because this will repeat the point at for t equal to 0. Okay, so now we say for t equal to 0, for this point here, we find the value of x just as we did here. X, we know that is 4 cosine of t, and y is equals to 16 sine of t. So for t0, then 4 cosine of 0, since cosine of 0 is 1, this will be 4. And then 16 times sine of 0, but sine of 0 is 0 times 16, it will be 0. And then the order pair will be 4, 0. And at this point, we'll have a vertical tangent line. Next, for t equals pi. So for t equals pi. For t equals pi, x will be 4 cosine of pi, and y will be 16 sine of pi. Cosine of pi is negative 1 times 4, that will be negative 4. And sine of pi is 0 times 16, still is 0. Now, the order pair now will be negative 4, 0. So another point at which we will have a vertical tangent line. So we write here vertical tangent line at that point. So we have 4 points. The first two, 0, 16, 0, negative 16, are the points at which the curve has horizontal tangent lines. And then we have 2 other points, 4, 0, and negative 4, 0, and at these points, the curve has vertical tangent lines.